All right, just a bit of super quick recap. If you guys are feeling lost, you can always go to the course by clicking on the course website, and this is the homepage for the website. And I'm going to go today. I'm going to go into visualization because we're going to start on. We're going to go to visualization. So I'm going to click on visualization.
Lost.
We're not seeing anything.
Oh, you're not seeing it? Oh, sorry. Let me. That's weird. Can you see now, or is it?
Yeah. When you hit
small, or is
record,
it?
it disappears.
Oh, the record blew it away. Okay.
I can't
Is that
find. Can you just share the link again? It's not showing up in my bookmarks.
This is the link here. Yeah. Well, if you go to the email that you got, it's under the PS here. So that's probably the best way. But I'll put it into the chat too. Okay. Yeah, we're bootstrapping. Chat. So there, it's in the chat too. So that's the home page, and the home page basically gets you everywhere in the course. So from the home page, we're going into section 2, which is visualization. We did section 1 already. And last week, because it was a short week, we did some slides and that's it. So we did part 1 and part 2 about just intro to visualization and intro to ggplot last week. And so this week we're going to start with, we're going to talk about visualizing numerical data, categorical data, and then we're going to go into this application exercise. Okay. So I'm gonna dive right in. So we're going to talk about numerical data now, visualizing numerical data in ggplot. Stop me anytime. It's much more interesting. So let's just talk a little bit about terminology. So when you talk about variables in data sets, there's a number of different kind of number of variables that you might deal with. Some of them are more interesting than others, but like a univariate analysis is a distribution of a single variable. So that's just like a histogram of a single variable or something like that. Bivariate data analysis is the relationship between two variables. And multivariate analysis is a relationship between many variables at once. Sometimes it's like y equals some function of lots of other variables, or other times it's just looking at a bunch of different variables within observations. When we talk about variables, there's a bunch of different types of variables, and this is important, and we're going to talk about it in some amount of detail, but just at a high level, right? There's two big groups of variable types. One is numerical variables. Numerical variables can also be sort of subclassified as continuous or discrete, depending on whether or not the variable can take on like any number or just integers, like non-negative integers. So like an example of a continuous variable, numerical variable might be the temperature in degrees Fahrenheit. So that's a good example. Does anyone ever have other examples of what like a continuous variable might be?
Height, weight.
Yep, height or weight. Yep, and how old you are. That kind of stuff. And then like a discrete variable, a lot of the time that's count information, like how many quarters do I have in my pocket? I can't have negative quarters, and I can't have half a quarter. So a lot of the time, discrete variables are counts, but they don't have to be. And then categorical variables are not numerical, but they sort of express categories. So can someone give me an example of categorical variable?
Male or female?
Male or female. Gender is a good categorical variable. Yep. And there's lots of examples of those too. The month of the year could be thought of as categorical. I mean, if you the word month with the number month is a discrete numerical variable. And categorical variables also can be ordinal or not ordinal, and that depends on whether there's sort of an inherent natural ordering of the variables. So like gender, for example, is not ordinal. There is no real ordering between male and female, But for example, like if you take a survey and they ask you to rate something between like very dissatisfied or disagree with some statement versus, so you might have a scale of 5 going from disagree to a little bit of disagree to neutral to agree to very much agree. That's an ordinal categorical variable because there's an inherent order in those data. So let's keep going and we'll see some examples of that. Okay, so the data set that we're going to look at today is from the Lending Club, which is this sort of website where it's like a peer-to-peer lending website where people can lend other people money, which is kind of crazy. It's not like banks. It's like just individuals loaning other people money. And the loans are all different. There's lots of different variables that define the quality of the loan, and you'll see from the data like that. And this is like also when you get a loan from a bank, that the ease of getting a loan depends on your sort of the variables that describe your ability to potentially pay back the loan. So there's different grades of loans, different interest rates depending on like how well the risk involved in giving a loan out. And just a detail that the data here is actually real data from the Lending Club, and it includes just loans made and not loan applications. And so that will inform you. If it was applications, it would look different, but it's just a detail. These are just loans that are made. The data is from this Open Indro package, which has lots and lots of data in it. And if we took a peek at the data, we can see there's 10,000 rows, so there's 10,000 observations. So that means these are 10,000 loans that we're going to look at, and each loan has 55 variables, which is a ton. It's a lot of stuff in there. So we're actually just going to subset it because it's too big. So I'm going to go to the next slide, and that's going to just show sort of like if I just want to take a subset to make it sort of tractable. And this code, I would encourage everybody actually to go through this, because you can walk through this in your RStudio, not now, later. But these are all our statements, and they're executed, and you'll see the results of and the slides actually are doing this when they render the slides themselves. So it's all for real. Anyway, so we're just going to select a few variables out of here. We're going to select 8 variables, and the code that does this is, oh wow, my mouse just did cookie stuff. Sorry. Okay, it's my mouse. The loans full schema is the actual data set name, and so I'm going to flick back here. And so we're piping the loans full schema into select, and we're going to select only these 8 variables: loan amount, interest rate, term, grade, state, annual income, home ownership, and debt to income ratio. And when you glimpse it, this is what you'll see, right? And when you use glimpse, if you remember, you'll see all of the variables, and then you'll see examples along each of the rows. You'll see example quantities of each of the variables. And in fact, there's a little more information about it. I'm trying to use my mouse here without making a mess of the slides. As you can see, sorry, my mouse isn't working. You can see that the data type is part of the glimpse. So you can see this is an integer, this is a double, and we're going to talk a little bit more about that. So next slide.
Could you go back? Could you go back one slide?
Sure. Back from here?
Yeah. So this is the whole data set. So it's got title, emp length, state, home ownership, annual income, verified income.
Mm-hmm.
And then you're taking it. So that whole data set is called loans full schema.
That's right.
And then you're piping it into loans by just selecting a subset.
So yeah, I'm taking, so I'm assigning loans. There's the expression. The result of this expression will become the data set called loans. And so to make it, I'm piping loans full schema into the select function. And the select function selects variables, so it'll select columns out of the full data set. And these are the variables I'm going to select, and that's what it's doing. Yep. So it's just taking those columns out to make it a little bit more easy to read. Is that clear?
Yes.
Okay, cool. So this is basically just this is the data dictionary, of that subset, and I'm just going to go through them real quick. So the loan amount is the amount of the loan received in US dollars. The interest rate is the interest rate on the loan in a sort of annual percentage rate kind of thing. The term is the length of the loan, which is a whole number of months. Okay, so it's only a whole number of months. The grade of the loan takes on a bunch of values between A and G. So A is the highest quality and G is the lowest quality loan. It goes A, B, C, D, E, F, G. The state's the US state where the borrower is. Annual income is the income of the borrower in US dollars. Home ownership has three values. It could be that that the borrower either owns their house, they have a mortgage, or they rent. And then the debt to income ratio is the ratio of the total debt to their income. So you take their total debt and you divide it by the income, and that's their debt to income ratio. Okay, so now let's talk about the types, right? This is all about data types, right? Variable types. So the first loan amount, first variable is loan amount, right? It's a numerical and it's continuous. I can in Lending Club, I can ask to borrow any amount of money. Okay, I'm going to borrow a non-negative amount of money, but it's continuous. I can ask for $1 or $1.50 or $1.25. So we consider it continuous, even though you can only go down to pennies, but it's, for all intents and purposes, it's continuous. Same with interest rate. That's a numerical. It might be 2.5% or 3.75%. So that's a continuous numerical variable. The term, because we said it was in a discrete number of months, it was in a whole number of months. It's numerical because it could be a 30-month loan or a 12-month loan. It's considered discrete though because it's only whole numbers of number of months. The grade is a categorical variable. It goes A, B, C, D, E, and it's considered ordinal because there's an inherent order in the variable. So A is best and G is worse, and then it gets worse and worse and worse, right? So it's ordered. State is also categorical, but it's not ordinal. You can make a joke, I suppose, about it, but it's not generally ordinal, right? Because there's Maine and Alaska and Washington, and there's no inherent order in the variable. Annual income is numerical and continuous. You can make any amount of money. Again, it's probably non-negative, but still. Home ownership, remember, it's categorical because there's only three values. It could be rent, own, or have a mortgage. And it's considered not ordinal here because it's not really inherently better to rent or to own or to have a mortgage. Like there's lots of reasons somebody might choose to have one over the others. And then debt to income ratio is just numerical and it's continuous. So hopefully that makes sense. Are there any questions about that? Any of these?
Could you explain?
Yeah.
Could you explain? I might have missed it. Just discrete in term, like how is it numerical and discrete? Like what does discrete mean?
Sure. So the discrete means it has it has a set number of integer values.
Whole numbers. Yeah.
Whole numbers, whole non-negative numbers. Yeah, so the term is the number of months, and the number of months is generally like 12 or 24 or 36, something like that. But it's not 12.2. Okay, so let's go into, so this is all about visualization. So we just did a bit on like the data types, but so so we're talking about numerical distributions. And so the first thing that we kind of sort of look at in numerical distributions is sort of what's the shape of the distribution. And there, people kind of categorize this idea of skewness, where like you might have a right skewed or a left skewed or a symmetric distribution. And right skewed means that if you look at the curve, it sort of goes up and then there's a peak and then it comes down and then it goes way out to the right more than it would go out to the left. And same with left, it's the opposite. And then symmetric is like like a bell curve, right? A normal distribution is symmetric, where it's mirror image between if you cut it right at the peak, that the left and the right sides are mirror images. The shape also has like a modality. Most things that we'll look at, if they're like, you know, probability distributions, most of the time they're unimodal. That means they have one peak. A mode is a peak. Bimodal is if they're like two peaks. And a lot of the time, a bimodal or a multimodal distribution is that way because there's some grouping of the underlying numerical along some other dimension that makes them sort of cluster in these different modes. And so a lot of the time, if you see a bimodal distribution, you might want to look at the data, slice it another way to see if you can tease out like why there's two different modes in that distribution. And then I guess there's a uniform distribution. Yeah, go ahead.
I just noticed something. So I just went to look at the slides. Yeah. And I see that there's readings with each class, huh?
Yeah, I forgot to mention that. I'm sorry about that. Yeah, they're not with each one, but not with each slide set, but there are readings. Yeah, I was going to go over that later, but I totally forgot about it.
Sorry. And I can't.
That's suggested. Yeah.
So if you could always go back and look at the reading too, I guess, if you have any.
Yeah, there are. So let's take a tiny segue into the readings. I'm sorry about that. Yeah, so if you go back to the course, so a lot of the slide decks come with these suggested readings, and they come from a couple different places. There's one book called these are online books that you can just click to. R for Data Science is one book, and then IMS it's this Intro to Modern Statistics. So you can pop over here and do these readings, and the suggested reading is just these chapters, and the chapters are relatively short. The books are fairly long, but it's suggested reading if you want to go do it. Yeah.
So would you like us to do it before a class or after? It should be done before the lecture, typically.
Gosh, that's a really good question. I think it should probably be done before the lecture. So from now on, I will give out suggested readings. I'll alert you to the suggested readings in the next section at the end of the class. Yeah, sorry about that. I missed that. Okay, back to shapes of numerical distributions. Okay, so we talked about modality. Uniform distributions don't have a mode because in a real uniform distribution, like a theoretical one, it's all flat. You have the same likelihood of getting any of the values, and so there is no mode. And then there are sort of descriptive statistics. There's the idea of the center of the numerical distribution. So the centrality you can measure by a mean or a median or even a mode. And there are different subtle differences between like means and medians. And we'll get to those later on. But in general, like a median is less sensitive to extreme values, for example. So if you have outliers in your data, you might use a median rather than a mean. But a mean is a nice metric to use for some other things that we'll talk about later. Can somebody's making noise? Can you mute? I don't know who it is. Thanks. Okay, so these two summarization metrics, the centrality, and then there's the idea of spread. And there's a bunch of spread metrics. One of them is the range. It's the maximum minus the minimum. That's like the total extent of the numerical distribution that you've got from min to max. It doesn't tell you a whole lot, but it is one metric. Standard deviation is a measure of variability. It's a much better spread sort of metric to use, and that's related to variance and the variability of the data set. And then there's this notion of interquartile range also. That's like the range of the values between the 25th percentile to the 75th percentile. That gives you sort of more of an idea of spread. If you don't have like a nicely shaped distribution. And then there's the idea of unusual observations, and we want to know, like in our numerical distribution, we want to know if there are unusual observations, not always necessarily to eliminate them or to sort of ignore them, but just to understand them. They could represent something important, or they could be noise in your data, but you want to be able to characterize your distribution with respect to that. All right. That's a lot of, oh, that's the end of numerical. Oh, no, wait, I think I'm out of, no, it's definitely not me. Sorry. All right. So we just talked about the shapes of numerical distributions, and a very popular way to visualize them is by using a histogram. So we're going to go into how do you make histograms in ggplot. So here's a very simple way to show. So we have the loans data set. We're going to take it the loan amount. We're going to make a histogram of the loan amount, which is the amount of the loan that was granted from to the borrower, and we're basically just going to say ggplot loans, which is that smaller data set. The mapping is just at the x dimension to loan amount, and then we're just going to plus that into geom histogram, and this is what you get. This is sort of the default that you get, and you can see it's kind of noisy and spiky, and you see the range here. It goes from like 0 to about around 40,000, so that's kind of interesting. The y-axis is the count. So for histograms, the y-axis is always the count of something. So basically, it's the number of times you see a piece of data that's inside one of these bins, and the bins are a little bit of an art form. If you don't set your bins in histogram, you'll get a little warning that says, hey, I'm using bins equals 30. It's the default. Why don't you go pick a better one? Maybe you'll get like a better looking curve that might tell you some more information. So let's go and do that. So if I have, like I said, it's a tiny bit of an art form. What you really want to do is you want to find a sweet spot for the number of bins or for the bin width. So this bin width is 1,000. So that means I'm going to have, if there's 40,000, if the loan amount goes from 0 to 40,000, I'm going to have about 40 bins to do counting inside of, and you can see that it's jaggedy. And now if I move my bin width, I'm just going to click over here. If I see a bin width of 5,000, you can see that the curve looks very different. Wait, something just happened. Did someone join? No. Sorry, that's someone trying to join. With a bin width of 5,000, you see now you kind of see sort of a more smooth distribution looking thing. It's not as spiky, and it looks like if I was going to characterize this, I would say, well, it's got a sort of a central mode around 2,000, and it's right skewed. You know, it looks kind of like a reasonable distribution. And then if I set my bin width really high, like to 20,000, now I get this thing that doesn't have much of a shape. I still have sort of the centralness and might be a little bit of a skewness, but it doesn't tell me very much. So there is no right answer for bin width, but you know, you want to play around with it until you get something that kind of looks reasonable. I don't know if there's a better way to explain that or not, but this is a nice example of that. Here's a really kind of a sweet spot, and if I go over here, it's kind of jaggedy, and I don't really get that kind of information that I want to see. So let's see, let's keep going. All right, so now I'm going to show you some code for how I'm going to do this customization. So we're going to do some stuff. We're going to add some labels. Like we've done this before in ggplot, but this is just sort of reinforcing, right? So this is the same code as before, except my histogram has a bin width of 5,000, which I found was a nice number. And then I'm adding some labels. So I'm going to add the loan amount along the x-axis because that's what it is, and the y-axis could be frequency or count. And then there's a title of the amount, you know, the amounts of the lending club loans, right? So that's that one. And we're just going to do a few examples of this. There's some other things that I can do relatively easily in ggplot that gives me a lot more information. So one of the things I can do is I can add a categorical variable to my histogram, and then I can visualize this. Basically, I'm slicing this histogram of amounts of loans, and I can see, well, of those in these different price ranges, how many were mortgages, how many were two people who mortgage their house, own their house, or rent their house, right? So that's a little more information about the nature of these loans, and it's kind of pretty too. So the way I do that is I do this fill with the home ownership categorical variable And then there's also an alpha here. The alpha blending basically just says, in the histogram, it just says, well, make the display have a transparency so that I can see the axes sort of shining through, so I can sort of get a better sense of what the values are. Otherwise, I wouldn't see the axes shine through from below. And everything else is the same. Okay, that's one thing I can do. Let's keep going. I could, instead of...
Can you go back real
Yeah,
quick
sure. Yeah.
to the code?
Uh-huh.
Everything else is the same. Okay.
Yep.
So all you did is fill equals home ownership, and then it kind of does like, I don't know, it's almost like a stacked.
Well, yeah, it is. It's a
Stacked
stack
column
it's a
chart.
histogram.
Yeah.
Yep. And what I'm doing is I'm saying fill it with this other categorical variable. So fill it with that variable, break it down, do that breakdown. Yep. And if I want it, so sometimes it's a nice way to do this, and sometimes I might want to see facets where that's what this one is. I can facet the histogram instead, and now I'm seeing on the same x-axis, I'm going to see these guys broken down by themselves, and I might get better, depending on the data, I might have, there might be better insight into doing it this way. And that code looks similar. In fact, it's up to here, it's basically the same from ggplot. I'm still filling with home ownership, but instead of it all being on one plot, I'm saying, well, facet wrap this guy by home ownership, by the home ownership variable, and give me 3 rows. That means 1 column. And so I can either put it over by doing the filling with home ownership without the facet wrap, or I can facet wrap it and see them all individually. All right, and keep going. Okay, now so we're gonna go from histograms to density plots. So density plot is a lot like a histogram. Sometimes it's explained like taking your histogram and getting a wet piece of spaghetti and laying your spaghetti over your histogram if your histogram was a bunch of blocks. That's kind of one way to think about it. But there's some things about the density. I think someone's trying to get back in again. Sorry. There's things
For some
about
reason, I'm able to admit her, so I've been admitting her.
Oh, okay. Oh, thanks. Thank you. All right, cool. Yeah, so if you could actually
I keep losing reception.
Sorry.
Okay, glad you're back.
Okay, well, it's recorded if you want to see it later. Anyway, we're talking about density. And so the thing with density is it's got an area of 1, and so it's normalized. So the area under the density curve is always 1. And so that's a different way to visualize your data a little bit. And like I said, it's like taking a limp piece of spaghetti and shaping it over your histogram. And it has the same characteristic as the histogram in that, oops, I can do an adjustment on sort of the extent of the smoothing. And so I can, if I have my adjust a small number, it's wiggly, it's very wiggly. If I change my adjust number to be a little bit bigger, it's a little bit less wiggly. It's the extent of the smoothing. And if I put something just a little higher, now I'm getting something that looks kind of like that sweet spot of even in the histogram, right? It looks a lot like my histogram with the bin width of 5,000. So again, this is something.
So adjust is kind of similar to bin.
Yeah.
But I'm kind of confused by the scale.
Yeah, the scale is different. It's something you just got to play with. Yeah,
Okay.
I mean, yeah. You're right. The scale is totally different. It's nice. You generally start with the default. The default is 1, and then you're like, oh, I got it, but I should make it bigger because it's super wiggly. And now you can customize your density plots like you did with your histogram plots. So this is your basic one where you're just adding, labels. It's always good to label your plots, right? So we want to get in the habit of labeling our axes and our title and that kind of stuff. And then we can go on and we can do some fancy stuff like analogously to the histogram example. This is the density plot with the fill, with the home ownership fill, but just using density instead. And what that does is it overlays these different categorical densities on top of one another. It looks different because the density is normalized to 1, and so you'll get different shapes, and you can maybe tease out some other insights from this versus doing it with the histogram, potentially. And you can do the same thing with the facet. Oops. You can do the same thing with the facet wrap, but it's not here. You can do the same thing with the facet. Is an example of that. All right. I'm going to keep going. Okay, so then another way to do, so we talked about histograms and density plots. Now we're talking about a box plot. So this is the box plot. Sometimes it's called box and whiskers plot. This is the code that makes it basically. So now we're looking at interest rate. It's a different variable, but I'm going to do a ggplot. I'm going to look at interest rate, and I'm going to just give it to this geom box plot. And the box plot has a bunch of stuff, and I'm just going to go through it real quick. So there's these whiskers at the ends, and they go to, I think it's a 5% and the 95% level. And so then they go, this is the interquartile range, so it goes from the 25th percentile to the median, which is the 50th percentile, to the 75th percentile. And then it goes out to the 95th percentile, and then these dots at the end, these are outliers that are beyond the 95th percentile. So that tells us a lot of information. You can make similar insights with this data as you could with the last data, even though it's a different variable, but it still is looks like it's a right skewed distribution because I have all of these outliers that are on that go out to the right, and on the left, well, it starts at 0, so it's unlikely that it's going to be left skewed, but it could be. Anyway, that's the box plot, and we can start playing with the box plot. We can box plot different.
Grace, mute yourself.
Got their. Can you go on mute, please? This is just a different variable called annual income, and you can see that this one has a lot of outliers, which is, I think, typical for people. You know, there are fewer people who make a lot of money, and then a lot of people make less money, right? So the median of this annual income is like, I don't know, that's 25. It's like $5,000 or $10,000. It's the median, and then there's a fewer number of people making 2 million, $1.5 million, crazy amounts of money. That's how you see you've got a lot of outliers, because these are all above the 95th percentile in the distribution.
These people are getting loans on
Yeah, I don't know why they're getting loans. Yeah, they're getting loans on Lending Club, which is
the
bizarre.
lending club.
Yeah, a bunch of shysters, who knows. So there's a bunch of ways to customize. So one of the things you'll notice here is in the box plot, there's this y-axis, but it doesn't mean anything. It's basically meaningless. So we want to get rid of it. It doesn't have any information. So one of the way, and so this does show that that's been removed. And the way you do that in the code is there's this theme thing. It's kind of yucky, but this is how you get rid of y-axis stuff. And it's just one of the things you kind of have to know. You basically, if you want to get rid of the y-axis, you cut and paste this little bit of code at the end of your ggplot, and that'll get rid of your y-axis. Other things that you might do is, we talked before with the histogram of overlaying categorical variables. We could do the same thing here. I've got an interest rate and box plots of interest rates, and I can slice it by the categorical variable of grade, right? So this is super clear, except for a couple outliers that, well, can anyone interpret this graph for me? Like, what's the relationship between grade and interest rate?
As the grade goes up, the interest rate goes up. So the worse your credit rating or whatever that, you know, the grade represents, then you're paying more interest rate.
Exactly. Yeah. So if a grade A loan, which is the best loan you can get, which means that you're very likely to pay it back, you get a very low interest rate. And the data is actually really consistent, except for a couple of these outliers, that as the grades get worse and worse, the interest rate that they start charging is ridiculously high, 30%. It's really high. And the code to do this is pretty straightforward too. So now I want the y-axis now, so I'm not going to get rid of it, and I'm going to say, well, the y-axis now is grade, and so ggplot's smart enough to say, oh, grade's a categorical variable. I'm going to map this y-axis into a number of these box plots, and then it just does it for you, and then you can have the subtitle, you know, sliced by the grade of the loan. And that's all you got to do.
Wait,
multiple box plots.
You lost me there.
Sure. So let's go back to the basic box plot here. So the basic box plot, you're going to do ggplot. And then you're going to say loans is my data set, then my mapping is this aesthetic, and I'm just mapping X to the interest rate, and then I'm going to box plot it, and then a bunch of stuff. If I go, I'm going to go to the next slide now. If I want to do the y-axis categorical variable, I'm going to add a y-axis. It says, actually, I want my y-axis to be grade, the grade of the loan, and so split this data into these by that categorical variable. And it does a lot of stuff under the hood. Clearly, it's grouping, it's ranking, it's doing a bunch of stuff. But you know, if you stick to this pattern, you can very quickly get this sort of, you know, plot that tells you a lot of information. You got all these box plots also sliced by the grade. Did that make sense?
Yeah, I'm just trying to remember what it looked like for the histogram.
It's
Yeah, it's different,
so
but
yeah, the histogram uses the fill aesthetic.
still,
Yep.
yeah.
So again, these are just things you kind of just have to know. There isn't necessarily like a super fantastic rhyme or reason, but once you know them, you just reuse them. You know, it's like you're going to end up, if you do this a lot, you're going to end up making your own little cheat sheet, or your own. You know, you're going to have a markdown that has a bunch of stuff in it that you go back to over and over and over, or you get really good at Googling stuff because it's all out there too. So yeah, that's just how you do it. Okay,
I have
excuse me?
I have a question.
Sure.
So this is kind of like not on topic, but I'm confused about on the homework, there is like, it was said sort equals true. I don't really understand what true means.
It means that you want to do the sorting. If sort was false, then you wouldn't sort. I guess I'm
So
not sure.
how would you even put it in if you're not gonna do it?
No, that's why sort that you wouldn't put it in, but if you wanted to put it into sort equals true, it just means sort the data.
You couldn't just write sort.
It's just how they do it. You could write sort if in another language, probably.
Does true mean anything else?
Nope, it's either true or false. Yeah.
Okay.
So
Thank you.
those are like Boolean variables of a function, and the arguments are either going to be true or false. Yeah. Yep. Yeah, it's just how they do it. Okay, let's talk a little about relationships with numerical variables. Okay, so if I have two numerical variables and I want to look at the relationship, the first thing I do is a scatter plot. So here we have debt to income ratio versus interest rate. This is kind of interesting, although it's not super informative. Like people with a real high debt to interest rate. Actually, I can't tell anything from this data, but it's interesting to see, right? If you want to do we've done a bunch of scatter plots, right? We map the X aesthetic to the X axis, the Y aesthetic to what we want to show on the Y axis, and then we plus it down to this geom point that the geom of point means to make the scatter plot. And there's a bunch of ways we can fancy this up. So hex plots kind of give you like a density overlay to give you the count of how often things happen. So if I have this, like if I have a bunch of data and it's overlaid on the scatter plot, I can see, for example, in this data with the hex plot, the lighter values happen more often. So in this case, there's actually a bunch of overprinting of these dots, but I can't see it just because they're overprinted. And I could make the transparency, the alpha here, but it still would, there's so much data, it would overwrite it and you would be able to see it. So the hex plot allows you to get sort of that sort of Z dimension up if you want to look at the counts of things. So here, for example, like I've got a lot of data. There's a lot of data where the debt to income ratio is fairly low and the interest rate's fairly low. These are, you know, probably high quality loans, and a bunch of others sort of one-offs that are all over the place. And I can like, if I want to also like zoom in on something, I might filter my data out, right? So if I want to look at the debt to income ratio that's less than 100, you can do the, sometimes I don't recommend doing this very often, but you can filter stuff in a ggplot, but it only works if it's a short expression. If it's a long expression, I would just say like make a new data set with like loans piped into filter and blah, blah, blah. And then when you do your ggplot, just ggplot that one table instead of doing all this crazy filtering inside of a ggplot, but you can, and that's what this is showing. This is just basically, it's getting rid of the greater than 100s, and then you can see a lot more detail down here where the sweet spot is in terms of the most of the loans are given. All right. That's it for numerical variables. It's 7:44. My plan was to go and do categorical variables. This is a shorter slide deck, and we can visualize some categorical data and then take our break and then go into the application exercise. So I think we'll do that. And I'll shoot for getting through this in 15 minutes, and then we can do our break. So I'm going into part 4 now, visualizing categorical data. We're going to go right into it. Okay. We are going to visualize some categorical data. So first, what did we just talk about? Okay, we talked about variables, numerical variables, and they can be continuous or discrete. We talked about categorical variables, which can maybe be ordinal or maybe not. So we're going to look at the categorical variables in that same Lending Club data set. Okay, and this is what we had done before, right? We got our loans full schema, and then we selected out just 8 columns that we're interested in just to make it tractable. And these are the same data that we've been looking at in the previous slide deck. Okay, so bar plot. So this is something that we can do. And again, ggplot's doing a bunch of stuff here, but what bar plot's doing in this case is it's saying, okay, I'm going to look at I want to look at the home ownership categorical variable. It's not ordinal, and there's only 3 values: mortgage, own, and rent. Okay, and if I just sort of if I ggplot that on geom_bar, it'll tell me the number of occurrences, the number of observations in each of those categories, right? So if I add these up, I'm going to get 10,000 because there's 10,000 observations in the data set. So this is just a simple way to look at the count of a categorical variable. So we're going to get a little fancier. I can break that categorical variable down by a different categorical variable. And in this case, I'm going to use the fill, like we did in histogram. I'm going to fill this thing with the grade of the loan. So now I can see for mortgages, ownership, and rent, what the breakdown in terms of the number of the different grades of loans are. So that's kind of cool. That's a little bit more information. And there's other ways to do this. So for example, I can show this data using this thing called position equals fill. There's a bunch of different positions if you do question mark geom_bar. This one fills, it basically makes them proportional. It normalizes them all to 1. So the counts all go from 0 to 1, which is 100%. That's not an actual count, it's a normalized count, but it tells you a little more information if you wanted to compare percentages of grades for these different home ownership types. And there's a nice slide here that compares the two. So this is a good question. I may have already given you the answer, but like, which one do you guys feel is like more useful if you wanted to look at the relationship between the home ownership and the grade of the loan? Like, how would someone interpret the data? Like, what would I be interested in? Like, maybe how many people got a grade A loan, for example, or what the percentage of people was who got grade A loans.
Yeah, I mean, I guess the normalized one is more useful for that. So you can kind of say like most people that got the grade A loans had mortgages, and then a little bit less owned and less rented, and then most people that rented had a am I getting that backwards? So most people
No, that's right. Yeah.
Yeah. So
Generally, yeah, I think you're right. That the higher the mortgagers got sort of generally higher grade loans, but it's not a super strong signal though. Yeah.
And the renters, you could see a little bit more, right? That they tended to get the F and the
Yep,
E's,
and they have definitely fewer grade A loans. Yep, and you really can't see that on the left-hand side. There's no way you'd be able to tell on the left-hand side that was the case. Yep. All right, so we're looking at these bars vertically. We can customize them lots of different ways. Like here's a nice way this is a really nice way to show. If you can just sort of flip it on its side and you can see, it's a little bit clearer this way. That shows that the renters get fewer grade A loans than the others. And the code for that is you've seen before. So now I'm going to go back one. So the code for this one, it said X equals home ownership. And if I want to flip it the other way, I just basically say Y equals home ownership. So that'll flip my column chart to a bar chart, basically. I'm still filling with the grade. I'm using the position equals fill to normalize it. And then I'm doing a bunch of labels, right? Because I want to describe what's going on. So the x-axis is proportion because it is the proportion of loans. It's not a count. The y-axis is the home ownership categorical. The grade is the other categorical that it's being sliced by. And
So
there's
since you're just saying home ownership, will it take the categories in the order that they appear in the data set, or is it alphabetical order? Because it seems to.
I believe it's
also be
alphabetical.
Yeah.
Yes. Yeah. And you can order it. Well, you'd have to figure out a way to order it. Like you could use a range to order it, I think. That's a good question, actually. I'd have to Google that. I don't know. And now we can get even more complicated. We can look at the relationships between numerical and categorical variables. And there's lots of ways to do this. And we're going to be wanting to be cognizant of the amount of information we put on a single graph, but we're going to go through a couple examples. So we talked about faceting and coloring of histograms and density plots, and we talked about box plots side by side. And now we're going to talk a little bit about what we call violin plots. And violin plots are actually pretty cool. They're kind of a density plot and categorical plot all in one. The x, like so if I make of this violin plot, the x is the home ownership categorical, and the y amount is the loan amount. So I have a loan amount on the y-axis, and then the squiggly line is basically a density line turned up on its side and mirrored about the middle. And it kind of looks like a violin a lot of the time. And that gives you a real good sense of like mode of the distribution and its tailedness, its skewedness, and that kind of thing. And it's a concise way to show it. And it just kind of looks cool too sometimes. Sometimes it's goofy though, it depends. Another thing that you could do is this, it's called ridges. And it's actually a separate library that you can pull in called ggridges. And it's an add-on to ggplot. But this is basically a density plot, but instead of overlaying, it offsets all of your categorical grade variable by this amount, and then you can sort of see these things. And it's kind of a nice way to visualize if you've got a trend in your mode, for example, or if the modality, for example, changes over the grade. Like, for example, you can see, like in grade A, there's this big mode, and then there's a little tiny mode way up at 40,000. But like on grade F, there's these two big fat modes that are more close to each other. And it kind of looks nice. Anyway, that's how you do it. I don't know if we'll get into doing that or not. And that's it. So we made it through categorical variables pretty quick. I think what we should do now is go on our break, and then we're going to come back and we're basically going to go through an application exercise that goes through all the stuff that we just went through. So we'll step through this application exercises together in our Studio Cloud, and we'll just sort of fill all the stuff in and just sort of do it as a team. So let's go on break and come back. You want to come back at 8 o'clock? And then we'll start right at 8, I think. Let's do a short break, and then the application exercise shouldn't take more than a half hour. Okay?
Okay.
All right. See you guys at 8.
Can we deploy the project before we go?
It's not a bad idea, yeah, because it will take a few minutes to start out. Do you know how to do it?
Yeah, I
wanna-
just did
I
it.
guess-
I just did it. So it's set. Okay.
Does everyone know how to do that? Maybe it's a good thing actually to do now. Because some people may not have done it yet.
Is it something that I can do later? I don't have Wi-Fi.
Oh, yeah, sure. Well, if you don't, oh, you're on your phone?
Yeah.
Yeah, then you're not gonna be
Is
able
there a
to.
way to see the screen at all by joining on my phone? I just pressed the phone call thing, but
I don't know actually. Hold on 1 second. You don't see the share?
wait,
Sorry?
what?
You don't see it on your phone?
Go to the email.
No, you're logged.
Zoe or Grace?
It's great. It's Zoe.
I thought it was Grace.
So Zoe's trying to
Yeah, she can't do it.
she's on her phone, but she should be able to
Keep
see.
yelling at me because you think I'm the one who has my
She can't
mic
hear
off
you.
on, but it's
Mom can't hear you. Grace, she can't hear you because you're on the headphones. Sorry. I'll tell her you were
Yeah, sorry, that
Sla-
all the noise is
snapping
me.
back.
I don't know why my phone
Where's
is muting.
Where's Lucas? Why isn't Lucas here?
He took a break. He's taking a break.
He
You
left.
guys take a break. Take a break. We'll come back at 8 o'clock. Okay. Take a 4-minute break.
Okay. Should I just not?
Not everybody. Lucas isn't back yet. All right, there's the reading.
Are we supposed to do anything else?
Nope.
So we're not supposed to do.
We're gonna do on Wednesday. We're gonna go through lab 2, and then we're gonna talk a little
Yeah,
about.
I usually put
project.
what's due for that week. So that's what you're gonna do. You don't have to print. You don't have to. Anyway, whatever. I'll show you how I do it.
Okay.
That's fine. I usually do
Yeah,
it.
it's a little wordy. The slide's a
I'll
little
show
bit
you- I'll
busy.
show you.
All righty. Do you guys want to start in on the application exercise?
Where are the instructions in the top?
Can you close my door?
I hear you yelling anyway.
All right, so do the readings, everybody, if you want. So I'm going to demonstrate, I'm not sure if everyone remembers how to get their application exercise loaded. So Grace, you got to do this too. So you can't do it. If you guys go to the home page, if you go to the visualization section, scooch down to application exercise, click on it, click on this guy, boop, and you'll get the GitHub. So just copy the GitHub, go over to RStudio Cloud, new project from Git, plug that guy in and go. Is everybody doing that? Did everyone do that?
No.
Do you want to do? Let's all do that.
No, I'm working on it.
Okay. I'm still showing, but I think this is probably too big, so I'm gonna unshare and reshare just my RStudio. So I don't know how small the text is here. Someone let them in. So let's see. Is that legible? Can you guys read all this stuff on here?
It's pretty small, but it's okay.
I'm gonna smallify it then. I can get smaller. Is that better? That should be bigger for you now.
That's good for me, but I
Okay.
can put my glasses on too. So there's no instruction file, right?
No,
There's
we're just gonna walk
okay.
through the application
Yeah.
exercise together, which means you guys can go off and do it if you want to race ahead. Fine. I'm just gonna go slow. So I saw this before, but it's just so funny. Funny looking kid is the R version. So is everybody at least this far? You've gotten your Star Wars application exercise from the website. You copied
Yeah.
it, stuffed it into RStudio Cloud. Grace, are you there? Grace, are you? I'm gonna click on Star Wars, and the first thing it says is, "Oh gosh, I don't have any of these packages," and I'm gonna install the packages.
You mean the RMD?
Yeah, click on the RMD, and the first thing it does, it says, "Oh gosh, I need all these packages. You want me to go get them?" Did you do that?
Yeah.
That's the part that takes time. Yes, installing all those packages. Does anyone stop me if I'm going too fast? Because I know some people may not have done this before, and I know Zoe, you can't do it because you don't have the network. But while this is loading, I'm going to go to this little gear and I'm going to preview in the previewer pane. I can do that asynchronously. I can just click there, and now it's set up. When I go to knit, I don't have to monkey around with it. I know it's going to come up in the viewer pane. So I'm going to wait for that to run, and then I'm going to knit the document. And then what's it going to do is it's just going to show me the default version of the. the document. And of course I have to install something else. All right, raise your hand when you're at this point. I'm gonna raise my hand because I'm visualizing Star Wars characters. Do you guys remember we did Star Wars before? We did a bunch of
I
stuff for
forgot how
Star
to
Wars.
raise my hand.
Well, you go to reactions and you click the little hand button, like I just raised my hand. So raise your hand when you can visualize Star Wars characters, when you can knit your R Markdown file. I'll make this bigger. Pete's hand is up.
Mail's up.
So, Lucas, are you working on it or what's happening?
Yeah, I'm
Okay.
downloading right now.
Grace, are you working on it or are you partying hard? Answer. She may have stepped out.
So now I could say she's a slacker.
Slacking hard. Where's Hazel? All right. Well, I guess Grace isn't there. Lucas is almost ready. When Lucas is done, I'm going to do a couple of things just to sort of get us. Okay, Lucas is there. Yeah, unhand myself. So we talked a little bit about this last time, but it wasn't super clear. I'm going to go and I'm going to load tidyverse into my console so that I can fool around in my console if I run into problems. So I'm just going to click this little arrow here, and that's going to load the tidyverse library into my console. When we talked about before, the knit
What?
environments.
We mean click this little arrow.
Can you see my mouse? Can you see my mouse?
Okay. Got
It's
it.
called run current chunk. So you can run all these chunks, and every time you run a chunk, it's like you can run them all in order, and you can run everything.
Or we could have just cut and pasted library.
Yeah, or you could have,
library type.
yeah. And so like if you want to glimpse Star Wars, you can either cut and paste it, or you can just click the little chunk thing. When you do that, it comes up in the console and it comes up into the source file. I don't kind of like that, so I'm going to just close that. If you just copy and paste, you don't get the garbage up in the RMD file. But you can glimpse the data.
How do
So
you
anyway,
close it?
you did a little
Oh, the
X.
X. Yeah.
Yeah. Okay, so we're just going to walk through the actual Markdown file, and it's going to tell us the things to do. So the first thing we did was we glimpsed Star Wars. And we did that in the console if you want, and you do it in the Markdown. So when I glimpse it, I can see there's 87 rows. You guys remember this? These are the Star Wars characters. Each row is an observation of a character, and they've got tons of attributes, but they've got 14 attributes. And let's just real quickly go through these because they're kind of interesting. And now we've learned about variable types. We can look and see for each of these what we're talking about. So we got a name, which is it's a character string, but it's a categorical variable in the sense that it's not numerical, right? It's basically these are just names. You could think of it as
So where does that come in? So I see it in the in between the I see that is that done by the database, or is that so where it says character integer?
This guy, yeah. Those are
Discrete,
inferred. Those are inferred by the data. They're not, and you can
inferred by
change
the
them.
data.
Yeah.
So you don't
Which
ever
is-
have to tell it the type of variable.
You do sometimes, yes. Like and it's called typecasting. It's like a programming thing, but sometimes you want to have the data to be integers, and they're not. They're floating points, and they're all 77.0. And so you have to cast it into an integer by saying as integer or as numeric. But those are special cases. Usually the data comes in, it says, oh, this is character strings, so I know it's a character, or it's integers or something.
So
Or
we
double.
actually looked at like the table. It would be a column that says name would be first, and it would just say Luke Skywalker, and then would be a column that says height, and it had all the
Well,
height.
that's a good, so how would you do that? So say you want to visualize the table.
Visualize. No, is that not
View.
it? What's it called?
View.
View, okay.
View Star Wars, and that will pop up in your file view, that table, basically the spreadsheet. And it doesn't say anything about the character, I'm sorry, the variable type, but it shows you the data.
Got it.
All right, so let's go back here. So now we've glimpsed it. We're like, okay, great, awesome. So the one thing about Tibbles, we talked about, and actually there's, in the next session, we're going to talk a lot about Tibbles, but one thing that Tibbles do that normal data frames don't do is you can have an element of an observation can be a list. And normally in data frames, you can't do that. But films, vehicles, and starships are all of list type. So that means that Luke Skywalker has been in these films. So you don't have to have a separate row for each film.
It's like a one to many.
Yeah, exactly. It's
relationship.
crazy. Yeah. It's super cool. Anyway, okay, so let's go to the next part. Okay, so the first task that we have is to modify the plot and change the color of all the points to pink. Okay, right now the color is this hex. So I don't know if you guys know about hex encoding of colors. It's hexadecimal, which goes from 00 to FF, and FF is 255 decimal. And anyway, there's three colors here. The first two numbers are the red amount, the second two are the green amount, and the third two are the blue amount. This is an RGB color code. And you can sort of roughly see that this is blue, and you can see there's not much red. There's 30 red, 50 green, and then there's 9 Charlie blue, which is a lot more. That's why it looks blue. Anyway, how would you change that color to pink? There's a couple ways you could do it.
Make the 3 higher, the 30 to like.
Yep.
No?
Yeah, because that would put more red in there, right? So you could figure out the hex value. You could probably go to like PowerPoint and do a color thingy and click it. The other thing that you could do though is well, the color, you can specify the color in hex numbers, or there's a bunch of named colors that ggplot supports. So a really super simple thing you could do is just to write pink. Yeah. So I'm going to do that because, and I'm going to rename.
Okay.
Now you got pink. It's not a very good pink, actually. It's kind of a crappy pink. But anyway, it's pink. Can everybody do that? I mean, this is kind of trivial. I know everyone can do it. But anyway, let me know when you're there. Or let me know if you have problems, like if you have problems knitting because of a syntax error or something.
You want us to put our hand up or not?
I don't know. What do you guys think? Is it, maybe just stop me. I don't
I'll
want.
I'll give you a thumbs up when I'm good.
Oh, does it go away? Does thumbs up go away?
Yeah.
Well, I'll give myself some applause. All right. Anyway, I assume everyone's been able to re-knit with pink, and tell me if you can't. All right, I'm gonna go on. So the next thing we're gonna do is we're just gonna do titles and labels and stuff. So it is very, very important, especially if you're gonna do anything with your data, if you're gonna show it to somebody, that you have to really make sure that all of your boring stuff like your titles and stuff are actually correct and appropriate and descriptive. I cannot tell you how many times I've tried to read graphs and they have been abysmally labeled, and it's very difficult to figure out what they're doing half the time. So I'm going to put in some meaningful titles, and everybody else can do that too. So I'm not sure what we're doing here. What are we doing? We are showing height versus mass. Okay, so it's mass versus height, I guess. Right? X is height, And I like to put units in. Height is in centimeters. And the mass is in kilograms. And then there's a third part that doesn't have anything on it. And you guys have to fill that in.
That's the subtitle or?
Yep. Subtitle equals size of percent per year. Okay, and I had to look this up. Birth year is the same as age because the way they represent birth year in Star Wars is something like before something happened. And so I think it roughly maps to age. It's like BC. A larger value is farther ago. And I think everyone was born before whatever this epoch was, epoch. And so they're all relatively near age. I think it maps pretty close to age. So anyway, I'm gonna knit. Let's knit. So, but we should be knitting often.
I got an error. Oh, never
Because
mind.
we think we'll get errors. Yeah. Yep. So you can see there's two really old characters here, and we know one of them has a high mass. So I think does anyone remember what that character is? Not very high and very, very heavy. Who's that character? Come on, guys. Anybody?
Jabba the Hutt.
Thank you. But there's another very old character here who's very short and not very heavy. Who's that? Anybody?
Yoda.
Dun, dun, dun. It's Yoda. I wonder if there are not very many Star Wars fans here today. Okay. Let's keep going. So now we're going to get into it a little bit more. Pick a single categorical variable from the data set and make a bar plot of the distribution. Okay, so that's kind of cool. So now if I wanted to know, like, well, let's find my categorical variables, where would I do that? How would I figure out the variable type?
I guess you could glimpse again.
Yep. So you guys probably can't see what I'm doing because your screen's probably full with your RStudio. Yeah. So if you glimpse it, you can see the column names and you can see their data types. So somebody pick a categorical variable. There's a bunch of them.
Oops, something's wrong. Hold on. So you just do glimpse.
Yep. Open paren.
Is homeworld a categorical variable?
Yep, it is. Turns out there's a bunch of these variables that are categorical, but there's a large number of categories, and it can become cumbersome. But so that's a good one. Let's do homeworld. Homeworld.
Yeah, I keep getting an error. Can you help me with that before you go on?
Yeah, sure. What's your error?
I'm just typing glimpse Star Wars and I get error could not find glimpse.
Because you didn't load tidyverse. So you got to go to the top and do the little click with the tidyverse because Star Wars comes with tidyverse. So you got to load that library. So line
No,
8.
I did it with a capital G. Sorry.
Oh, okay.
Yeah.
All right. Okay.
Okay, sorry.
All right,
So
so-
hold on. Slow down here. So you're looking for a categorical.
Yeah. So Shamil suggested homeworld. I'm gonna
Yeah. Okay,
use
let's
that one.
do-
Then you can see if you got it. Oops, you got it. You may see that it didn't evaluate, and that's because on line 43, there is a line in the R chunk that says eval equals false. You've got to remove that for it to evaluate.
geom is bar. Bar
Geom
plot?
bar. Yeah. Geom underscore bar. Yeah. Now you see a couple of things in the graph. If you used homeworld, is the labels are all overwriting each other. So let's see if we can make that look a little better. What would we do?
I didn't get it. Something's wrong.
You want to show me? You want to share your?
Well, hold on. Let me just try and execute this chunk here. Okay, so is it commented out or something? Because when I execute it, it comes correct.
The eval is set to false. So if you just delete it, I'm not sure if that's the issue or
Oh,
not, but
okay,
it
so
won't
eval-
evaluate it.
All right, yeah, you went a little quick. I didn't read this. So a little bit of
Oh,
sorry.
okay. Yeah.
Eval equal force because the current code is there and is not valid once you replace it. Okay, so then eval equals true. So that's kind of just like commenting something out is eval equals false.
It means just don't. It just means like print it out verbatim. Don't try and evaluate it in R as an R statement.
Yeah, that's what happened. It came out just as the code. Sorry, I'm caught up now.
Okay, so do you see your graph? You have homeworld on the x-axis and count on the y-axis.
Yes.
Okay, and you can see that you can't read anything there because
Yeah.
there's so many. So I'm going to change the axis, and I'm not sure if this will work. I think it ought to though. If I say y equals homeworld, then I think it's going to flip my column chart to a bar chart, and I'll get, yeah, that's cool. Now I can see all of the homeworld names and their
Okay, let me
counts.
try that. So you do plus y equals.
Nope, just change your x to a y in the AES and the mapping.
What?
It says AES x equals homeworld probably in your code.
No, it just says AES homeworld.
Oh, really? Well, so it's inferring the argument, which is x. So that's equivalent to saying x equals homeworld.
Okay.
So why don't you do that first? Say x equals homework
Yeah.
and hold home and renip, and you should get the same thing. And then change your x to a y, and that's gonna flip your chart sideways.
And then we could go into that little, can we do that thing where we change the frame height?
Yeah, you can change your figure height to be higher if you want to. Sure, you can do it.
Wasn't there
Fig
like wasn't there like a override setting on the right here by run or something, or?
If you say fig.height equals, I don't know, 10, then it'll be lots higher, and then you'll get more spacing.
Wasn't there
There's other
another
ways.
way to do it in the top bar?
There is, but that would set all of your graphs, and you don't want to. You only care about this graph for right now because you don't know what the size of your other graphs should be. Yeah.
So you don't have eval equals true. You just got rid of eval.
I deleted it. Yeah, I just deleted it.
And then you did, how did that work? Fig height.
Oh, made it higher, and yeah, it's a little bit. It actually doesn't even fit in my frame anymore, so I'm going to make it a little bit less. But yeah, it does what you would like it to do, which is to give you a little bit more room between the entries. There you go. Yeah, so 8 is a nice number. It separates data and it shows you. So cool. Is everyone there? Is anyone not there? Speak up if you're not there, and then we'll go on if we are all there. Grace, are you back yet? She's gone. All right. Let's go on to the next one. Pick a single numerical value and make a histogram. So that's number, well, there's no numbers here. It's line 52 for me, but it's around 52 for you. So let's make a histogram. If you don't know where to start, I would go back to the slides. there's lots of good histogram examples on the slides. I can shoot you over a link if it's helpful.
Okay.
Here's some start. Here, let me put this in the chat. If you go here, you can copy and paste out of there to see starter code for a histogram. So I'm gonna type my histogram in. I need to figure out what variable I want to use. So if we go back to Glimpse, let's see, what's a good histogram? What's a good,
Slow down, just give us a little time. Can we just try it a little, or?
hell yeah. What do you want to do? You want, I'll just be quiet.
I'm still going and getting the code real quick, just.
Yeah,
Slow down a
sure.
little.
Sure.
Just went in the wrong pair.
Maybe somebody, can we talk about numerical value? Did somebody use a numerical variable that they like? Maybe we'll just use that one.
Birth year works.
Cool. So I'm waiting, but I'm going to type in mine just real quick. Just for fun.
I mean, how do you avoid like making a mistake typing the variable name? You just always have to glimpse. Is there a way that you can just automatically?
Sometimes it will autocomplete for you, but in this case, it doesn't seem to autocomplete. One way is if you go down into the console and you type Star Wars and you do a $sign, it will give you a bunch of things you could choose from. That's one way to do it. Or just type it and, make sure you type it right. I don't know.
Hold on, I got an error. Not sure
No
why.
show. You want to display your screen?
Hold on. Incomplete expression. Let me see. Okay, I'll share it, but I'd like to be able to figure it out. I wish I could figure it out real quick.
Well, I won't tell you.
Hold on, I gotta figure out where you are now.
I have a question.
Mhm.
It's very silly. Where do I find the instructions for this?
I guess there
Yeah,
aren't
you-
any instructions.
So they're in
But there's like the lab guide. Isn't there like the words?
they're in the document themselves. It's in the
RMD.
exercise. Yeah, it's in the R&D file.
No,
So
but I
we're
have
You
the
just
file open.
Yeah, we're on like line 50. It says this time no starter code is provided. You're on your own.
where are you,
Mm.
Grace? How far are you?
I haven't started that. But we are cleaning dishes.
Okay.
I'm trying to find
Well-
like you know how the homework has like
Yeah, no, there
instru-
isn't that. It's in the R markdown. So you would knit it and then read it.
Okay, I guess let's read it then. I've already knitted.
Okay, good. So just read from the start. Yeah. So Jackie
Yeah,
on line 53.
We're up to line like 48 right now, but
It's okay, I'll figure it out.
Yeah. Try and catch up. You should be able to. So you're on line 53, you said ggplot,
Yeah.
right? You see that? And then the next is the data set.
Loans, yeah, okay.
I'm sorry, but I don't know where to find exercise run. It says put your answer to exercise 1 in, but where's the question?
Are you on the application exercise?
I'm on the very beginning of the lab.
Yeah, we're not doing
Okay,
the
we're
lab.
doing the application exercise. It's if you go to the homepage
Yeah.
and go to visualizing numerical data.
The homepage. All I have is homeworks and labs.
Okay, I'm gonna just, or Jackie, do you want to show her where the website is?
Yeah, so this is the homepage here.
No,
I'm
that's
sorry,
not.
I'm sorry,
Go to the
I'll show
website.
you. Sorry, hold on. Yeah, so it's this one, data science and our home.netify.app.
Okay.
And then it should look like this. And then we're on unit 2, which is visualization. And Daddy just went through these slides. And now we're up to this one, which is application exercise. So the first thing you gotta do is go to the GitHub. And then copy the code like we did before.
Yeah, I can do that. Okay, I found it now.
And then copy it in RStudio. And then when you get to RStudio, you run the markdown file and then it'll start like taking you through like the first thing will say add labels for title X and Y. And that's like we're just walking through that.
Okay, I can do that. I got it loaded. Okay, bye.
So why do I still have this error, honey?
So that error is from the last time you executed the chunk, not from when you knitted. So try and execute the chunk again, maybe.
It did.
Oh, you didn't close so this is just syntax, but line 53, you need to close the second paren on ggplot. Yeah.
Oh. So how do I figure stuff? See, that's the stuff that always gets me.
Yep, it's syntax. Yep. And click
How
on
do you
the
figure that out?
just by practice.
Uh-oh, still problems.
Well, execute the chunk and see what happens.
Just did.
Do it again. I didn't see it. No, that's not. I don't know what that.
Gotcha.
Yeah.
Okay, so I can't knit if I've got the.
No, you can. I don't know why the knit did the knit not work. Are you sure?
Oh,
Oh, so you've got on line 44. It looks like you've got a typo. If you look at let's look at this because this is a good example of an error message that actually might be meaningful, right? If you look, it says unexpected symbol, and then the line below it says
hold on. Where am I seeing that?
bar plot. It's like, I don't know. It's in the red, but it's like at the bottom of the first chunk of red. It says fig dot height equals
8G.
Yeah, so I think probably your
I
fig
guess
height.
yeah, somehow it's typing glimpse or something. Okay.
And you got an L there too that you after the 8. So this is just like writing code. I would just recommend that knit very often, or execute your chunk very often, like every time you make a change, because once you get 2 or 3 errors, then you're going to get really lost. So try and stay on top of the execution so that that doesn't happen. So that's cool. That's a nice histogram you got there. Alrighty. Well, you were there. You want to keep going. So you've got a single numerical variable and you made a histogram out of it. Okay. Now let's pick a numerical variable and a categorical variable and make a visualization. So think you're on mute, maybe? Can't hear you. All right, I guess I'll take, I'm not sure what's going on. Jackie, are you still there or no? Can't hear you. All right, I'm gonna take over, I guess. So if we pick a numerical variable and a categorical variable, I'm gonna stick with the theme of histogram, and I'm just gonna I'm gonna fill it with a categorical variable. So I'm gonna say fill equals gender's easy. If you use some of the categorical variables with lots and lots of values, it becomes really messy very quickly. So I'm just going to do this real quick and see how that goes. Here it is. Okay, cool. So now I've got birth year, and it's sliced by this gender categorical. So I don't know if you guys can hear or not, but oops. Couple of things come out to me in this is all the old characters are male. There's lots more male characters than there are female characters. Female characters are relatively young, and there's one character without a gender. Yeah, that's all kind of interesting. So should we go on? Let's see. What's the next one?
Can we do that?
What?
or-
I'm sorry.
Can we do it,
Yeah.
or
Do
do
what?
you have a lot more, or?
No, there's two more. That's it. So yeah, do you guys want to? I didn't hear anybody talk, so I just kind of kept going. Do you want to do? Did you see what I did with the
No,
numerical?
let me give it a try and see if I can do it.
Which one are you on? You're on numerical categorical?
Yeah, I'm just trying to decide what kind of plot to make. I guess I'll make a bar plot.
Can we go up a little bit?
Sure.
I'm on 40. I'm just.
Okay. Pick a single categorical variable from the data set and make a bar plot.
Yeah.
Okay.
Equals. Wait, why did you change the bar plot to something height equals 8 instead of eval equals true?
So the eval part was just, it was turned off. The evaluation was turned off, and I made the figure height 8 because there's a lot of data, and so I wanted to fit all these homeworlds onto the graph, and so I wanted to make the figure height a little higher than normal. That's all.
Okay.
If eval was false, then it won't evaluate the expression that's in there, and so it won't give you a graph.
So it's really hard to, you have to keep, there's no way to just like have like a glimpse handy. I guess you gotta just keep running the glimpse to know what's in there, huh?
Well, you can, if you have your data set in the viewer pane, you can go there and look. Like,
But that's where I'm typing the code, right?
no, it's above.
What's-
The viewer
One thing
is
at a
above
time.
the source.
Yeah, can you see my screen?
Right, but don't you type the code in that box normally under source?
Oh, I thought you said console.
Ugly bar graph.
Yeah.
Wait,
Well,
what's
if you wanna
homeworld?
click- What is homeworld? It's a
Yeah.
categorical variable of the homeworld of the character. You can, so Jackie, you can type glimpse down in the console. I thought that's what you're saying.
Yeah, that's what I did, but you gotta keep doing that every time you wanna make a plot, huh? Or like,
You could, there's lots of ways to do it. I mean, you could get the data dictionary out. If you say question mark Star Wars, and then it's over on the right, you can see the data dictionary there. If you want. Gracie, do you have a question?
I'm working through it with Hazel.
Okay. Yeah, sorry, those are the three ways you can see the data set.
Quick question for for two categorical variables, could you
Yeah,
what would be a good graphing method? Like
well,
should we facet it, or
I would start, if you look at these guys, I would start looking at it like maybe this kind of thing.
a fill
Like,
bar? Yeah, that's what I was thinking.
Yeah, like a filled
Okay.
bar plot. The thing
So you
is
could do
with this,
fill and then you could do, yeah.
yep, you're gonna run into some explosions in terms of the number of values. So this data is not perfect. It's got a lot of categorical variables, have lots and lots of values. So you could do a couple of, well, one, you could avoid them. So you could look at sex and gender. Those are both have a small number of values. The rest of them have a pretty large number of values. You could try and subset your data. Like you could look at the number of homeworlds that have greater than one entry, for example. So most of these homeworlds only have one character. So you could remove those from the data set by filtering. I think I did that once where you could say, let's try and do
So
that because that's,
you would put homeworld greater than one, or would you have to change that, because I know the greater than less than works numerically.
yeah, you can say Star Wars, and then you would have to pipe that to, oh no, yeah, you first have to find it and then you have to filter it. So you could say filtered, you could say Star Wars.
No, you can
pipe that.
you can directly pipe filter in the ggplot. That's what I've been doing.
No, yeah, you can, yeah. The thing is, if you want to just look at the homeworlds that have greater than one, you need to first figure out which ones they are. So you need, I did it over here actually, because I ran into that. Let me just
Would
see
it be
what
easier to just do that in the console, just to keep your code less messy, or does it not matter?
I would subset the data set before I plotted it.
Okay.
can we see what you're talking about
I
and
did
stuff?
the
I got a
Instagram
question
one.
on mine too.
Sure. I'm sorry, there's too many people talking. What was the question?
I did a histogram, but it looks like a bar graph.
You want to show me your code?
Sure, it looks exactly like yours.
The code or the graph?
The code. My graph doesn't.
Did you
This is my-
knit?
Well, I ran it, and this is what it ran into.
Yeah, you ran it in the console, but if you knit
Yeah,
it, can you
if I
hit knit?
knit it, it looks differently.
Yeah, hit knit, click knit. So the when you knit, the
I knitted,
the R markdown gets updated.
but it still looks like a bar graph.
Well, it does look, the histogram does look a little like a bar graph, but the interpretation is that the x-axis is the birth year and the y-axis is the count. It's the number of characters that fit into these different bins of birth year. So that's what makes it a histogram. Which is actually, like, if you had a categorical variable, it's sort of histogrammy too, but a histogram is generally only done on numerical variables, so that's kind of the difference. Like if
Right.
yeah,
I completely zoned out.
did that make sense?
Not really, but it's okay.
Well,
Are you done with the other person? Because I got a question too, but it sounded like you were in the middle of it with somebody else.
Grace
Well,
gave up, I guess.
Call me the other person.
No, right before you, that he was talking, was
That
it
was
Shamil maybe?
Lucas. Lucas was looking to. We were talking about how do you filter the data set to show the categorical variables that have fewer values if you wanted to remove some of the values from the data set.
Oh. Well, can I show you mine? Because mine,
Yeah,
I don't
sure.
understand what.
Okay, sure.
So, what does yours look like?
Which,
The one you just did with the,
the histogram?
yeah.
I could show you. So this is just a histogram that's sliced by a categorical, right? So it's a histogram of birth year with gender, the fill is gender.
Yeah, mine doesn't look anything like that.
Do you want to show me your code?
Yeah, sure. Hold on a second. Maybe my bins have to be bigger. So I did a little bit different. I did gender and birth year. Is that what you did?
Birth year and gender, yeah.
Okay.
Yep, that's right.
So
You did a
this
G on bar though. So when you do a G on bar, it's going to behave differently. It's going to try and give you, wow. Did you use position fill? I'm not sure what that is. Oh, you did position equals fill. So position equals fill is going to give you normalized values. This is first of all. So if you actually get rid of position fill and re-execute that, but
you mean
the
fill?
bar, no, on 61, it says position equals
Okay.
fill. So that won't give you a histogram. That's going to give you a bar chart, but a bar chart and
Yeah. So
histogram are actually
here's
very
what
similar.
let's just explain. Take me through this. So this is what I was looking at as my example.
Right. So this is a bar plot, not a histogram. And really the big difference is that the bar plot is really going to look at counts on categorical data, not on numerical data. So it's kind of similar, but they're different enough. You don't get this same level of tunability with the bar chart. I'm not sure what you would get if you did a geom bar on a continuous variable. It may look a lot like a histogram. In fact, it probably would, but you can't set bin width and stuff like that. So I would use histogram in that case. If it's a numerical value, you want to use variable, use histogram for a distribution.
So get
So
rid of
let's see.
this.
Yeah, say geom underscore histogram. Yep.
Okay.
I didn't do that good subsetting in this one. A different one. I think you have to group by and then count if you
So
want
it's
to.
not really age, right? I mean, so birth year, the earlier the birth year, the older they are.
Yeah, yeah.
Okay.
So yeah, it's effectively similar to age. I can't remember what it is. You can look quick. Oh, actually, it's in the data dictionary. We look in the.
If you're asking about the age thing, it's before a certain thing.
The-
It's called
the-
Before the Battle of Yavin.
Battle of Yavin. Yeah. When was the Battle of Yavin? Do you
BBY.
know? Yeah. When was the Battle of Yavin?
Well, that's zero BBY.
No, I know,
That was,
but
I think that was
like, I
the
think-
first film when they blew up the Death Star.
okay. Because they're all positive values and some of them are very small. So my guess is like the Battle of
Yeah,
Yavin
that's when they
happened.
blow up the Death Star in A New Hope.
Okay. So there's no characters who have a negative BBY value. So they all were born before the Battle of Yavin. And so they were some age. I guess probably this was at the Battle of Yavin, probably when their birth year was. Well, that, yeah, it's measured in second. Right. Anyway, bigger is older. All right, let's go back to categorical and categorical because it's okay. The easy way to do it is look at like sex and gender because they're small numbers. The hard way to do it would be to look at, well, let's look at some other ones that are a little more difficult to word. Let's see. Two categorical variables. Okay, so I'm going to say species. Categorical variables. Visualize a relationship with two variables. Yeah, I guess I'm going to do a bar. So I'm going to use fill. This will just be ridiculous. But it'll be fun to watch.
So what kind of plot do you want to use with categorical variables?
A bar plot, or you can do a bar plot with fill to look at two categorical variables. Violin plot, that's Regis. Yeah, I mean there are other ones, but those are the ones that were shown in the example.
Did we do an example of two categoricals? Who's categoricals?
Just like the loan with home ownership and grade. That if you go
Okay.
two down, that one
Yeah.
there, yeah. So, but like if you do, whoa, what's this? Yeah, that's right. Yeah, it's ridiculous if you look at large number of values. You can't get anything out of it. You got it.
Would
You
you
have to use.
Would you mind telling us how to filter? Could you finish that question that I asked?
Let me figure it out. Okay, so I think I'm gonna have to say, let me just do a quick Star Wars. I've got a group by species. I've got a count. And then I got a filter. Let's see if I'm not sure if this will work or not. It's out there.
Can
Oh,
you go
you're
back
not
up
seeing-
to?
What's that?
Can you go back up to that code?
Sure. Who's
Line
showing?
66.
Oh, do you want to display what you've got? Let me just take over this
You
one.
want to see us what we have? He's
Well,
on
if
our
it's
reveal-
categorical, you don't have to filter. You could just plot.
This is what I have. I don't understand. But look at this. We made this. Isn't that cool?
Which
Wait,
one?
what do you have?
We made this one. We changed it to eye color instead of gender.
Nice.
Where
We're trying
do you
to be
show
unique.
it?
I'm showing you line 65.
Line 66. Yeah, that's incomplete expression. But
Yeah, it doesn't want this.
no, I was just trying to figure out how to do it. I don't know the answer to that.
Fuck, I told her I get her to accompany my math homework. Where's your math homework? She's in a math class. She's in Calc 3.
Okay.
How are you gonna break it? Can you help me break it to her?
Hey, Grace, can you go on mute, please?
Yeah, sorry, what?
Can you go on mute?
Yeah, but can you help me?
I don't understand the question.
This isn't working.
What are you trying to do?
The two categorical variables. I'm sharing my
Okay,
screen.
so-
Can you see it?
Yeah, so delete line 66. So the filtering's too complicated for right now. So if you go, well, did you plot it on Star Wars? And if you like, just pick like gender and sex because those have small number of values. So you can say, well, look, you need to go find a pattern that you can copy. Go up a little bit and yeah, copy one of those. Yeah.
This.
Well, the AES part, yeah. Yeah, plug it in there and then change the
Instagram.
yeah, so if it's categorical, you want to use a bar chart. Just a bar. And then change your variables to categorical variables. And I would just do one like sex and gender because they have small numbers of values, even though it's repeat, but yeah, run that and see what you get. Oh, bin width isn't going to work because that's for histograms. Yeah, delete
What
that.
do I use then?
Just delete it.
Just 20 or no?
Nope, just delete. Yeah, there. That's like that. So there's an example of two categorical variables. That's not a terrible example. So you take a look at what it's saying. Like you're looking at the counts of categorical variables sliced by another categorical variable. Yeah,
What's the other one?
Okay.
High
yeah,
color.
if you do that, you're going to get lots and lots of information that's going to be really difficult to
Yeah, that's what
detail.
I did.
Yeah. So I can show you how to subset it. It's a little bit of work. Let me just make sure I got it right, though. Filtered by.
Two numerical variables and two categorical variables.
Again, I mean, without doing the subsetting, if you use gender and sex for two categorical variables, and then if you pick two numerical variables, you can look at the violin chart, for example, of gender or something like that with age or something. Go back to the violin chart and see if you can make a violin chart with some of those data. Like, let's see what I use. Let me just look and see what I use quick.
Yeah, maybe
Oh, I
just show us and then we could work on
Yeah,
the
okay.
last one by ourselves and
Let me show you what I
Check.
did. Yeah. Sorry, it gets a little complicated. So, okay, so
I'm
I
gonna
did-
sign off, guys.
okay, thanks, Pete. Nice to
Yep.
see you. Thanks for coming.
Mhm.
What Grace just showed is what I did too, just because it has a small number of values. So the two categorical ones was this bar chart where we're looking at the count of gender sliced by sex. And then the next one was the two numerical values were height and age, and the two categorical ones were hair color and gender. So that's kind of a little bit of
so take us through the code real quick.
Sure. So ggplot, can you see what I'm pointing at?
Yeah.
Okay, so I'm ggplotting Star Wars. My aesthetic is X and Y are height and birth year, and I renamed it to be age, right? So those are my numerical variables. And then I added color and shape, right? And so color was hair color, and the color of the dots is the hair color, and the shape is the gender. So there's only a triangle and a circle in the end. I didn't get showed up for some reason. And then I made a geom point out of that, and then I labeled it, right? So it's a scatter plot with shapes and colors in it, basically.
Yeah, all right, cool. That's a good one. I'll try that one.
Yeah.
And then I'll sign off, or I'll sign off and then I'll try it.
Okay.
Thanks.
I'm working
any-
on this. Did everyone else leave?
No,
Oh, no, okay. I'm working.
I'm still here.
Oh,
it's gone.
Just
so you know.
there's a way to filter the based on the counts of stuff, but I think it's probably something we can work on a little bit later. I can share the code later when I do it. It'll take me a few minutes to figure out though. It is 9 o'clock though, so I think we can officially wrap up and people can sign off. Whoever wants to stay can stay, and if you want help. But I did want to mention that there are readings. If you wanted to do the readings, I would suggest it to help sort of solidify some of the stuff we talked about. And it's all up there. If you just go up onto the homepage and go into the section, the readings are under the parts, the relevant parts. So let's just quick talk about on Wednesday. We're gonna do lab 2, which is gonna be a lot like what we just did here, except it'll be a little bit more sort of on your own. And there is more of a narrative to talk you through the different parts. I wanted to spend a little bit of time on the project, so if it's optional, but some people might be interested in doing a project, and I'd like to talk through with people if they're interested. And Grace, you definitely should do a project because what you're trying to do would work perfectly in this stuff. And then there's a couple of details on the homework where you need to do some installing of packages that aren't they don't happen automatically. So I would just want to clarify that one up. So that's what we're going to do on Wednesday. So anybody can drop if they want to, and if anybody wants to stay on, I'm going to stay on. I'm going to work on this filtering exercise, and this. If anyone's got any questions or whatever. So, bye if you want to go, and stay if you want to stay.
I feel like we need to figure this out. Can we do the last one, please?
Review the
I'm
last
working
one.
on it now.
So we're talking about 2 numerical variables and 2 categorical variables. Yeah. Yes.
So there's no homework before Wednesday, right?
If you could do the readings, I think it would be helpful. But no.
What are readings? Where do I find these things?
Okay, so there's a thing called the home page, which I've been loosely calling it a home page. It's the website of the course.
Oh, okay,
And
okay.
it's this guy here, right? If you click on the week that we're in, which is visualization, the readings are in the page. Can you see this, Grace?
Yes, I can.
So if you click on this, that's the reading. You just click on it. It'll bring you to some stuff that you can read about data visualization in this online book called R for Data Science. And it goes through a lot of similar stuff, but it says it's using different data, says it differently. A lot of the same ideas though are there. Okay.
Where was the
Okay.
cheat sheet that Lucas was talking about?
Okay, I'll just meet with you tomorrow.
The cheat sheet is in our studio. If you go to help and then you go to cheat sheets, there's data visualization with ggplot2. There's a nice cheat sheet there. So if I click on, do you see that one? If I'm gonna click.
I'm not following you. I'm doing it myself. Let me just see if I get there the same one. I'm gonna open another RStudio window because I don't want to lose. Like I'm in the middle of a line.
Let me do it. No, it opens a new tab. Oop, it just closed. Oh no, downloaded a PDF file. Sorry, it's a PDF file, and it's 2 pages of lots and lots of stuff. But it's actually pretty good.
I see manuals, references.
Under help,
Yeah,
you're in our studio cloud, and you're in help.
yeah.
And you go to cheat sheets.
Cheat sheets. Oh, I did help over in the on the right pane. And there's a bunch of manuals and
I don't know where that is. Where's that?
references under.
Oh,
under-
that, no, yeah, no, I'm sorry, no, it's it's the help, it's the help menu item on the top. Yeah. On the top.
Which
of
one
it.
do you recommend? Data visualization?
With ggplot2, yeah. And that'll download a PDF, a 2-page PDF with a ton of little cheaty things on it, which is pretty cool.
Okay. Hmm. So what slide would I find the example that you were just showing where you can shade and what are the other things? I can't remember what they're called.
Phil? I'm not sure what you.
Yeah,
Okay.
I'm trying to
Which-
do the two numerical values.
With 2 categorical values?
Yeah,
So you could use like in the aesthetic, you can use color and shape to qualify the points on the scatter plot. That's what I would do.
in the aesthetic. So
AES.
after X equals Y
Yeah.
equals.
Yep, and color equals, shape equals. Well, let's look at that cheat sheet, see what else there is.
Yeah. Can you show
Size,
me?
you can change
So
the
how would I
size.
know, like on the cheat sheet, how to put that in? Like where does it go after X equals Y equals? Is it inside the parentheses, outside the parentheses? So it's under AES, right?
Yeah. Well,
Size,
the AES in this cheat sheet are just telling you, like, what are the AESs you can do? I think it kind of
Yeah.
assumes you understand the syntax.
syntax,
But
yeah. Is
it's
there a slide
inside-
that I
Yeah.
can reference?
Sure. Let me go get it. Let me go find it. Here. We are talking about numerical data, so I'm gonna go here.
I mean, under ridge plots, I got the fill and color here.
Yeah,
Yeah,
I mean,
so
here,
it's the
like if you
same.
look at the scatter plots, like, can you see what I've got
I'm
here?
I'm in the wrong deck, I think. Hold on.
I mean, this doesn't have great examples, actually. I think if you use,
So it's inside the. I just closed it by accident. So I got X equals Y equals and then a double parentheses. So this is all inside the double parentheses.
show me what you're talking about. I'm not quite sure.
You see it now, or
I do, but I don't see any code.
so?
Oh, here.
Do I
Okay,
put
yeah,
it
yep,
here?
that's
Do I
right.
put it
Yep,
here, or do I put
No,
it
no.
here?
No,
Here.
comma after the comma. You have to say color or size or shape or what else? Color, fill, size, shape, line. There's no lines. That's it, actually.
What should I do? Eye color for color.
Yeah, skin color, hair color.
Am I the only one on? I feel like I'm taking up all your time.
No, it's just Grace and Zoe, and I think they're both.
So then I want to put the titles in. I do that after geom point.
Yep. Say plus. You need a plus after geom point. Yep. And then do you remember how the title stuff, the syntax for that?
Title, right?
No, you have to say LABS. Labs is the big guy that you do stuff under. Yeah, and then open a paren. Oh, it has to be lowercase though. L. Yeah, and then open, and then you say title.
No, it
equals
didn't give me the stuff.
open paren.
Yeah, it's really dark in here. I can't see anything. Regular
tab.
friend? Okay, yeah.
Yeah, and then there's all all your helper stuff. Yeah.
So this is,
You need a quoted string. Double quotes. Yeah.
and then subtitle is another plus.
No, it's a comma. So you don't close the parenthesis. Yeah, do a comma, return. Generally, we want to put that on a separate line, but it doesn't matter. Yeah, subtitle. You want to type it, spell it right.
Yeah, why, all right, subtitle equals, or do I put this on top of the other place?
Yeah, this you can say by eye color and gender. something like that.
Isn't there another thing, another place that was on top of the symbols? Didn't the other example have like, here, I'll do it. So now that's it?
Well, you missed typed subtitle. It's typo. You have a typo in subtitle.
Yeah, see, that's the stuff that always gets me.
Yeah, maybe you can't see it so good. Maybe make it. Maybe you should make it bigger or something. I don't know. And then you need to close paren. Yeah, that should work. Yeah, the error stuff in the RMD is not fantastic. That's why executing the chunk really makes. Oh, that's interesting. Birth year, height. It's kind of interesting. Yeah, it's sliced by I can't remember.
So how do I change these?
What do you want to change? Oh, those are they are specified by the color or the shape attribute. So you would say add another item like a comma return, like before the paren. Yeah, comma return color equals. Well, just put it on the same line as yeah, comma return. Yep, color. And then the title of the color would change. So you could make it color equals, yeah, and then like capitalize gender or something in a string. You gotta make it a string, like quoted string. Yeah, quotes as a pain in the ass in this in our shape equals. Yep. See if that works. I wish it would bookmark where you were too. You don't have to scroll down every time. Yeah, there it goes. Cool.
Okay, thanks, honey.
Okay, honey. Bye. Bye, Zoe. I left before I stopped. Oh, because Zoe's still. Damn it.